Hello and welcome. Today, modulus for year 13. This is the question that we're going to be doing. It's an inequality. It's the modulus of x minus 1. Take away 5, close modulus is less than 3. I included this question in one of my synoptic papers and I was writing the solutions today. So I came across it and I thought what a nice question perhaps to discuss very quickly. Today I'm going to do actually two solutions. In my paper I only show one, the very first one that you're going to see, which is a graphical solution. But it illustrates this particular question, a lot of the things associated with modulus, which a lot of students find hard to grasp. So let's have a go at this. So where do we start with this with a question like this? We got an inequality. And this doesn't look pleasant. We have to say it's a double modulus. I mean, where do we start? So if I had a question like this, my starting point will be some graphs, try to actually see what this thing looks like. And of course, I need to set it less than 3. So I will draw the line y is equal to 3 and just see what part of my graph lies below that line. So we're going to concentrate in sketching this particular part. So where do we start? Well, first of all, I'm going to do some little sketches. I don't have a ruler for this board, so it's going to be a little bit difficult, and my drawing skills are not great without the right equipment. So we got the line y is equal to x, first of all, which we all know what it looks like. Let's actually put arrows on the axis. So it will look something like this. Okay, and then of course the line xy is equal to x, and then we're going to consider the line y is equal to x minus 1, no mods. So the line y is equal to x minus 1, it will look something like this, and it will be intercepting the y-axis at -1. Okay, but of course once we mod it, as soon as it hits the x-axis heading towards the -1, obviously on the y-axis, it will reflect and it will be something which looks like that. Of course, this point here is +1, and also this will be +1. Okay, so now I have up there the graph of y is equal to the mod of x minus 1. Now what happens, forget about the outside mod, I'm just looking next at the graph of y is equal to x minus 1 modded -5. Well, quite clearly that's a simple transformation. It will take the graph down by 5 units. So this sharp point, also known as a cusp, I'm going to write it here, it will translate 5 units, so it's going to reach the point 1, 5. So I'm going to do another graph here to actually show this. So this is my axis again. So this will now go to 1, 5, somewhere here, not to scale, of course, a sketch. 1, -5, I put 1, 5, 1, -5 there. I write stupid things sometimes, I want to shout at myself. Okay, so this is now my x and my y axis, and of course the graph will be something like this. Okay, do we need this particular points? The answer is we don't, but it's nice to actually know what it is. So let's go back to the original graph and just do a little bit of an analysis and just consider, okay, that's the graph, of course, of y is equal to x minus 1, and then we modded and we got this particular thing. What are the equations of the individual lines that I'm seeing there? This one here and this one here. Well, quite clearly this is the original y is equal to x minus 1. So I'm going to label it. So that's y is equal to x minus 1. What about the one that got reflected upwards, the one that got flipped? Well, this reverses signs. So it's a transformation. It's a transformation minus f of x, if you want. So it will become minus x, okay, minus x plus 1. So it will reverse, or you can put in a bracket with a minus at the front. Okay, so now we need to know, all right, what about these two lines? What are the equations? Well, let's think about it. This is the line y is equal to x minus 1. in this position here, we translate it down by 5 units. So take away 5. So this is actually the line y is equal to x minus 6. Having it in this form is actually useful to find where it crosses the x-axis. For example, I can see by inspection here that when I put x is equal to 6, okay, I get y is equal to 0. And what about this particular line? Well, that's quite clearly the line minus x. That's where it was originally, minus x plus 1. And I translate it down by 5, minus 5. So now this is y is equal to minus x minus 4. Okay, very badly written. I do apologize. Okay, so again, I can find the coordinate of that point because quite clearly by inspection, the number that I need to put in there is minus 4, which is positive 4. And of course, it will take me to 0. So I do have these coordinates if I need them. What about this point here? That actually I can get it directly from the equation that I've just plotted up there, the whole thing. When x is equal to 0, that's the mod of minus 1. The mod of minus 1 is 1. And take away 5 is, of course, negative 4. So I do have all this information. It's useful sometimes when I'm doing this kind of work to have a feel for what is going on. Okay, so far I'm on this graph. Here it is in detail. I have the equation of the equations of the individual lines if I need to do any algebra. So that's the line y is equal to x minus 6, and that's the line y is equal to minus x minus 4. Okay, now I have obviously one step to go, which is to mod the whole graph. So this is the graph, this is what it looks like. I need to mod it. I'm going to do that on this side of the board. Let me get rid of the microphone so I don't trip on it. So what will happen? Let's draw some axes first of all. So there's my axis. And of course, when I'm going to mod now the whole thing, whatever part of the graph is above the x-axis will stay as it is. But this section here will flip to the top. So the shape that I'm going to get, this is my 6 here somewhere, and this is my negative 4. I have these sections as I have them on this graph. So I'm just kind of shading it just to actually show you what I'm actually doing. So these two bits are there, but this section will flip to the top. So the point 1, negative 5 will go to 1, positive 5. Let's say somewhere here. So that's 1, positive 5 now. And it will look something like this. Not to scale, of course. What about the coordinates? That's, of course, the negative 4 still. That's the negative 6. This is the negative 4 on the y-axis that got flipped, so it's going to go up to 4. So I have again all my information here, apart from one thing, of course, which is what are the equations of those 4 lines that I've got here. 1, 2, 3, 4. Very easy to find. Okay, first of all, this part is there. It hasn't changed in any way. Therefore, the equation of this line segment will be y is equal to x minus 6. And similarly for this one, that is y is equal to minus x minus 4. What about this part and this part? Well, first of all, this section is the reflection of this section about the x-axis. The equation of this line is x minus 6. When it flips, it will reverse signs. So this will become y is equal to minus x plus 6. Minus x plus 6, the negative of that. That's the reflected part. And similarly, I'm going to reflect this section to the top. The equation of the whole line is minus x minus 4. When it flips to the top, it's going to become y is equal to x plus 4. So now this is very useful for doing algebra, because when I'm looking for intersections, I can actually solve simultaneously by looking at each line separately. So let's return now to our target, which is to solve this inequality. First of all, we have to think about an equation. So we're going to set this graph, which of course is the graph of y is the mod of x minus 1 minus 5. So this is what's plotted there. and I'm gonna set it equal to 3 rather than less than 3. So this is 4, so let's put a line, let's do it in green actually. So it's a horizontal line that looks something like that. So that's the line y is equal to 3. So, and I can see intersects my graph in 4 places, and I can find this intersections very, very easily. To find this intersection on the far left, I'm going to say minus x minus 4 is equal to positive 3. So x on the right is equal to negative 7. So this point here, if you want, is negative 7. Okay, what that do with my board rubber? It's in my pocket. There we go. I prefer actually ordinary cloth. It's much easier to rub than this professional sort of rubbers. Okay, we're gonna look at the next one, which is this intersection here, which I'm marking it with a dotted line at this point here. What's the coordinate there? Well, this is the line y is equal to x plus 4. So x plus 4 is equal to 3. So this simply will tell me that this is minus 1. So that's minus 1 in there. And so on. The third intersection is minus x plus 6. This equation is equal to 3. Put the x on the right, and then I've got x on the right, and that's equal to 3. So that's 3 here. Oops, let's put it with an arrow, probably better. So we're consistent, 3. And lastly, when I'm intersecting this line, which is x minus 6 is equal to 3 again, I'm going to get x is equal to 9. So let me extend the axis a little bit. So that's my y, that's my x, and this is 9. So I'm almost done. I need to solve the inequality. My graph is less than 3, so I'm looking for this section here. I'm going to put it in thick black pen. So my graph is below the green line for this section here, and there's also another section on the other side. And of course I have the coordinates, and therefore I can now write my final answer to this. And the final answer is my x must lie, looking at this bit here, between negative 7 and negative 1, or, which you can write in words if you want, is lies between 3 and 9. And this is my answer to this particular inequality. All right, was that hard? I mean, just assess the question a little bit. This particular question, personally, I will call it probably 1, 2, 3, 4.5, using my usual stars that I use in my books and in my papers. It's quite tough, and I mean, to actually go through all of this and think about how to do, it's quite challenging. Graphing skills are not usually good for the majority of students, so that can be quite daunting. But and this is the solution I've actually put on in my paper, on the synoptic paper that I included this particular question. But because it's very difficult to explain when you're writing a solution, unless you're putting tons and tons of writing, there is another way of doing this, which is will aid your understanding about what modulus is. So we're going to look at another approach now in this lecture and solve the same problem purely algebraically. Okay, let's first of all think of a couple of expressions before we make any start. And let's say, what does that actually mean? X minus 2 modded is equal to 5. I'm sure we can all solve this particular equation straightforward. I'm not asking for that. I'm actually trying to interpret it. And this is the interpretation. Think of a number line. And it says your number x, which you're trying to find, the distance or the difference, if you prefer, from 2. So this is your 2 on this number line. X differs from 2 by 5 steps. So it's telling you it's either 5 to the right, therefore your number is 7, or it's 5 to the left, and therefore your number is -3. And of course you can check it very, very easily by inspection. You didn't need to do that, but to try to interpret it. 7 take away 2 modded is 5, and of course -3 minus 2 is -5, modded is 5. Okay, what does it actually mean if we put an inequality? For example, let's change the numbers a little bit, and we put a plus there, and we put there, for example, is less than 3. Again, this is some kind of difference, okay, but we got a plus, so it's not really a difference. We need to think of that as the modulus of x minus -2 is less than 3. So this now says what you're trying to find, your x, the difference, that's this minus here, from -2 is less than 3 steps. So wherever your x lies is within 3 of your -2. So adding 3 to the right is going to be 1, and take away 3 to the left is going to be -5. So your numbers, all these numbers which lie between -5 and 1, are of course your solutions for this particular problem. Okay, so this is what's the meaning of the modulus in perhaps a sense that not a lot of us have actually come across. So we're going to try to interpret this, what we got up there, in a similar kind of way. So where do we start with this particular one? Okay, we're going to start first of all with the interior of the outside modulus. What it says up there, let's write it here actually, it says mod x minus 1 minus 5, all modded. Okay, so what I'm going to do is I'm going to replace this x minus 1 by another quantity. Let's call it capital A, I don't want to use y. So that says a minus 5 is less than 3. So now we can interpret it in exactly the same way we've done graphically with these inequalities. So that says your A, so that's your A line if you want, instead of saying the x-axis, your A axis, capital A axis. So it says the difference from 5, so there's your 5, okay, is less than 3. So your A lies anywhere between 8, adding 3 to the right, and 3 to the left. So I can actually say now that my A lies between 2 and 8. Fact. But of course, there is no such thing as A. A was my construct in all of this. A are called the modulus of x minus 1. So essentially that says the mod of x minus 1 is between 8 and 2. Okay, more inequalities. How do I do now with this two-sided inequality? The best way to deal with something like that is to actually split it into two separate things. So I'm going to split this expression into one bit here and one bit there. Let's look at the one on the right. That says the modulus of x minus 1 is less than 8. Interpretation. The difference of x from 1, so there's my 1, is 8 steps. So that means I can be as far as 9, because I'm less than 8, so I can be as far as 9 and as far as -7. So my numbers, I'm going to use a red pen to actually show the range there, because we're going to need to combine the two expressions at the end, and numbers which are between -7 and 9. Okay, this works on the right hand side of the inequality. What about the left? This now says, I'm going to write it back to front, it says the modulus of x minus 1 is greater than 2. Another number line. The difference of x from 1 is more than 2 steps. So if I add 2, I'm going to get, of course, 3 there. And if I take away 2, I'm going to get -1 on the left. But be careful, because now it doesn't say I'm within are more than 2 steps. The difference of my x, wherever my x lies, is more than 2 steps from 1. So I'm actually now using a red pen outside the 3, more than 3 if you want, forever to the right, and less than -1 forever to the left. So if you look at the two expressions, let's put them onto a single diagram actually to actually see it. So we have some critical numbers, and we have, let's put the 1, and then we're having a -1, we're having a 3, we're having a 9, not to scale of course, and we have a -7. This inequality works for between -7 and 9, it must work here, and it must at the same time work for to the right of this. Let's put a little dot there, and it should be open really, using, I don't know, in GCSE you use open there for something like that, and like this, forever to the right. And therefore, looking at this diagram, the solution of this particular inequality will be x is between -7 and -1, or between 3 and 9. And I think that's the answer we got when we done it first time round. Quite something. I mean, this is not obviously, I wouldn't say it's not sensible. It's actually very, very sensible if you understand this kind of stuff, and if you hate drawing graphs, of course. But it's something that perhaps I wouldn't recommend. And I didn't put this particular solution in my paper, because to explain all of this, I have to write an essay, and I hate writing essays, guys. Okay, I'll be back soon, okay? And for the time being, who's laughing now? See you later.